and we will carry on. So we've talked about floating point numbers. Careful when you use them. Array is just a group of values of the same type or of the same data type. So you've got an integer array. So you've got value 1. This is declaration and initializing at the same time. You should note that there is no limit on the number on here. However, this one says you intend to allocate 5 memory spaces for your array. At this stage, you are just saying, sorry, the value at position 4 should be 10. Position 4 in the sense that you're counting from 0, 1, 2, 3. So array indexing is from 0. And index means that the nth position. So in this case, if we assign 10 to the 3rd position, or it's actually 4, then call it position 3. So if we read from position 3, the value of x will be 10. So that takes us through common code for accessing the elements of an array. So normally we use a loop, in this case a for loop, or where we have 4, we initialize the value, which is int I equals 0, and then we have the condition or the end statement, and then we have the increment, which means start initialize a variable called I to 0, and then increment it by 1 until you get to less than 7, which is obviously 6. And then we access each element of this array, which is the flicker array, and then we are assigning it to the value of brightness of this LED pin. We are using analog, right? So we are using pulse width modulation, which is not just a 1 or 0, but varying the values from 0 to 255. So we take a note of this. It's on page 13. We'll revisit it in a minute. Common things, so I can run through it. We've got arithmetic. This means x equals s plus 3. You can do arithmetic manipulation, the adding, subtraction, multiplication, division. And similar to what I wrote earlier, which means if you look at the chart window, basically 5 divided by 2, if you declare them as integers, you get an answer of 2. But if you've got 5 divided by 2 declared as floating points, you get the accurate answer. So we have typecasting, which means you can convert something like a floating point to an integer by using this particular condition or typecasting. So in this case, if you have something like 3.6 and you do a typecast on it, i's value will be equal to 3, meaning you're just converting the floating point to an integer. The same way you can typecast an integer to a floating point and vice versa. So this is where C got their name, meaning you can do this arithmetic manipulation like x plus plus, where x is the variable name. X plus plus simply means x equals x plus 1. X minus minus means x equals x minus 1. You can play with minus minus x and plus plus x to see the difference in value. So in the same way you can do, if you're adding a different variable or a different value to x consecutively, you can do x plus equals the new or the other variable, and that will add them. So what that means is that if you go to page, this particular page 13, if you want to increment I by 2, you can say I plus equal 2, and then we increment in order of 2, and you skip the next index each time. So similarly, logical decisions, something like if x equals y, remember it's not single equal, it's double equal sign. So when you are comparing two things, this is the syntax for it. Double equal sign, this means not equal to, less than, greater than or equal to, less than or equal to, and greater than or equal to. So similarly, you can use true or false, which is 1 or 0. This actually is like Boolean logic or Boolean operation. It's similar to using AND gates or gates in electronics or at the low level of the architecture. So in this case, if we have x, if x is greater than 0 and less than 5, then something should happen. And the only way the code following this will execute is if the whole condition is true. And you can use different expressions as well.